Okay, so coming back to to discuss the design hierarchy. So I gave you an example of turning Korean into an English, and assume that you gave instructions to computer to write some code for a certain application, and says that let's say it generates a code like this. Okay, so this is the code written in certain language. Could be Python, could be Java, or anything. I'm not going into details of that. But this is not certainly which computer understands. Okay, so computer do not understand this. So just like Korean, written Korean, you were not able to understand. It turns into something which you can kind of like read it, but you cannot understand it. It's called the assembly language. There is a layer which an assembler converts into assembly language. Okay, and then there is a guy called maybe another process which converts this assembly language into machine code, okay, which is what we call the stream of ones and zeros. Does anybody know here what are these ones and zero? What do these represent? Yep.
Isn't it binary code?
Yeah, it's binary, but what are these in actual world? One, what does one represent? And what does zero represent? Yeah? Hmm? On and off, yeah. So 1 corresponds to on or high voltage, or 0 corresponds to 0. Just like this, for example, this is 0 state and this is 1. So computer, even this Mac or your phone, no matter how complex they are, down the line at bottom, at most lowest level, it only understands this. Everything turns into ones and zeros. So computer understands this. It may be a complex code or a snippet of code which you can not understand. Only computer understands. Okay. So this code runs on some physical components which we call digital logic components. So again, if you are an engineering major, you will be studying or computer science major, you will be studying these components later on other courses. But these are generally referred as digital logic gates, which are in turn composed of transistors, as just a diagram of a transistor. And the actual transistor is implemented on a device like this, which is called semiconductor. Again, I'm not going into details, but this is a diagram of a material, the physical material, which is semiconductor. That's a chip, actually, on your phones or on your computer. Okay, and the electrons flow from one end to another end. So what you write in a natural language, like write me a code to run a loop for 100 times, it eventually passes through these procedures and run on this physical thing. Okay, so this is a complete design hierarchy. So what you write is on high-level language, it turns into assembly code, machine code, passes through logic gates, and eventually run on semiconductor. Okay. The focus of CAC 1010 is learning high-level language with utilizing AI effectively. This is the additional thing which I have incorporated only in this semester. This is the first time we're incorporating usage of AI. Okay, that's here. All right, any question so far?